Hey guys, this is Mr. Sal. This is just a quick lesson on some dot plots and also finding the distance between means and also finding out how many mads are between some values. Thanks for watching. Don't forget to like, subscribe, and comment. Gross. We'll take care of it later. Below is data collected for a number of M&Ms in 30 small and 30 large bags of M&Ms, so 60 total numbers. As you can see, a small bag contains 1.69 ounces, while the large bag contains 3.14 ounces. However, the actual number of candies varies. The mean and mad for both small is, on the next page you'll display these data. That sounds good. So a lot of numbers up in here, but it gives us a lot of information to compare. So for the small bag we have a mean of 54, and for the large bag we have a mean of 103. And then the mad for both of those, 1.47 and then 1.48. Actually, we're going to take those, and we're just going to round them up to 1.5 each. That'll make things a little bit easier for us, which is kind of nice. So now take a moment in the space and create a dot plot for the number of M&Ms in the small bag of M&Ms, and create a dot plot, a second one, for the large bag of M&Ms. Alright, so just to help us get started with the dot plot, we can see the highs and lows for both the small and large bags. Alright, so that helps us set up the lines for the dot plot, and we just need to put the dots on, right? Alright, so I got 30 dots there for the small bag in red, and we'll do the next one in purple. And here we go for this large bag right here. So, 2 different dot plots, one for each size bag. That looks pretty good. So yeah, it's a total of 60 bags, but 30 small and 30 large. Alright, so that'll bring up some questions on your dot plot below, well, above, I guess. Circle the mean for each of the data set. What is the difference between the mean for a small bag of M&Ms and the mean for a large bag of M&Ms? So let's go back and see what they were. Alright, so for the small bag, we had a mean of 54 right here. So that would represent this column of dots. And for the large bag, that was at 103 right here. And we can see there's a lot of values for both of these, in both of these mean values. So what's the difference between the mean for a small bag of M&Ms and the mean for a large bag of M&Ms? Well, the difference is subtraction. So we are going to be subtracting these. We got 103 minus the 54 for a total of 49 candies. 49 M&Ms is the difference between 2 averages for both bags. Number 3, the mean absolute deviation for both sets of data is about 1.5, which we had done already. Approximate the number of mads between 54 and 103. Alright, so between 54 and 103, we know there's 49 candies. So how many mads does that represent? We'll just divide this by 1.5. And that will tell us how many mads separate the two means. 32.6 repeating mads. Now if we consider what we had talked about last time, is it would be highly unusual for it, well, it is usually highly unusual for a value to be beyond 3 mads away from the mean. But in this case, we're looking at 32.6, which would be unheard of, and that is because of the size of bags, of course. One is, well, really large, and the other is not nearly as large. Almost twice as big, or half as big, depending on how you look at it. If we were to look at the range for both of these, right, or the spread, if you will. So for the small bag, it has a spread of 9 candies, whereas the large bag has a spread of, what is that, 8? 8 candies. So we could say that the small bag has a larger spread, or we would, in this case, a larger range. That just means that there's a bigger difference between the high and the low. It doesn't mean it's common, though.
It's harder to count.
Alright, so number 4, the distance between the means was 49, which is about 32.6 repeating mean absolute deviations. We can just fill it in these boxes right here. Suppose that a 2.17 ounce bag of Skittles has a mad of approximately 1.5, same mad as the others. There are an average number of 57 Skittles in a bag. There's the distance between the 2.17 ounce bag of Skittles and the 1.69 ounce bag of M&Ms, which was the 54. So the distance between the two would be, the new one is 57, and then we'll just subtract that 54. So that is 3 candies. So we'll rewrite our answer for this part. 3 pieces of candies. How many mads would that be? Well, we'll take the 3 and divide it by the mads, the size of the mad, 1.5, and that gives us 2. So 3 pieces of candy is the same as 2 mean absolute deviations units. Suppose that a 14-ounce bag of Skittles also had a mad of approximately 1.5 with a mean of 360 Skittles. Measure the distance between the means of the 14-ounce bag of Skittles and the 1.69-ounce bag of M&Ms. Okay, well, the mean, they said, was 360 for this new bag of Skittles. And the 1.69-ounce bag of M&Ms had a mean of 54, so we're just going to subtract these. So that's 306 candies. Rewrite your answer in part A using mad as the unit of measure. Alright, so it was 306 candies. And the size of the mad was 1.5, so we'll just divide these. 204 mads. That's a lot of mads. Alright.